Hi, today we're going to discuss operations with sets. So let's consider two sets A and B is given. So A consists of 1, 2, 3, 4, 6 and B consists of 2, 4, 6, 8 and 10. So a union of a set is a set that's going to include all unique elements of both sets. The notation is going to look like this. This means union of two sets. It resembles letter U, although it's not. And all you do is you're going to list all the elements that you're going to see. So it's going to be 1, 2, 3, 4, 6, 8, and 10. Please note that we do have, like, for example, 2, you have it twice. You have one time here, one time there, but we're only going to list the unique elements. So no repetitions. The order does not make any difference. One other thing that is important to know, if you ever do a set union with an empty set, you will automatically get the same set. So A union empty set is going to give you A. Doesn't matter what A consists of. The other operation that you can do is an intersection of two sets. So an intersection is when you're only going to include elements that are in both sets. So if you look at these two sets, so this is the symbol for the intersection. So what do we have here? We have 1 only in set A, we have 2, which is in both sets. 3 is only in the first one, we also have 4, and we also have 6. So 2, 4, and 6 only, right? Because those are the only elements that are going to appear in both sets. Can use 1, cannot use 3, cannot use 10 or 8. It's only 2, 4, and 6. One other thing that's important to know, if you ever do a set intersection an empty set, you will always get an empty set. Okay. Let's move on. So let's try to do some examples. So if what we have here is set A is given to us and set B is given to us, we need to do a union. So a union of these two sets is going to take all the elements that we see there. So it's going to be 1, 2, 3, 5, 6, 7, 8. Again, the order does not make any difference, but I just put them in order. A intersect B, only the common elements. So the only common element we actually we have 2 common elements. Those are 3 and 6 only, right? Example 2, set C, set D. So set C union D is going to include all the elements. So it's going to be 1, 2, 3, 4, 5, 6, 7, 10. The intersection here is actually going to be an empty set because you have no common elements here. Yes, it is possible. Okay. One thing that is always good to know, what does an intersection or union, because sometimes you have to work with sets that are represented by Venn diagrams. So what does a union and what does an intersection look like? That's provided that sets overlap in some way. So union is going to include all the elements of both sets, so we are going to shade the whole thing. So the whole entire thing shaded would represent the union. But the intersection is only going to be the common part, which is this overlapping part. So that is what the intersection is going to look like. Okay, let's move on. So I have 3 sets here. I'm going to show you problems that involve operation with 3 different sets and how to do that. So you have sets E, F, and G. So E union F union G, because it's all union, you don't really need parentheses, and you're basically just going to list all the unique elements here. So what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, and 10. Now, when you do have parentheses in these types of problems, you treat it the same way as you treat parentheses in arithmetic problems. You are going to do what's in parentheses first. So, what we need to do here is we first need to do the union of E and F. So the union of E and F is going to be 1, 2, 3, 4, 5, 6, 8. Correct? Those are E and F together, and then you want to intersect that with G, which is 5, 7, and 10. And there is only one element. Since this is intersection, we're looking for common elements, and there's only going to be one element, which is 5. Here we have the intersection of E and F. We're going to do this first. So intersection of E and F. Common elements. We have 2 and 4. Right? E 1, 2, 3, 4, 5. This one's 2, 4, 6, 8. 2 and 4. And then you want to do union of that with set G, which is 5, 7, 10. So the final result here is going to be 2, 4, 5, 7, and 10. E intersect the union of F and G. So we got to do union of F and G. Let's copy E first. And then we do the intersection, the union of F and G. So the union of F and G is going to be all the elements from these two sets. So it's 2, 4, 5, 6, 7, 8, 10. And we do the intersection here. So what is going to be there? It's only 2, 4, and 5. Okay, we could do this by first writing the union of E and F, but here's one thing that I want to show you. Whatever that is, after that we're going to have to do an intersection with an empty set, and as I mentioned earlier, this will always be an empty set. You don't really need to worry about finding the union of E and F. It would not matter what it is. Okay. Moving on, so here's an example with the Venn diagram. So what you see here are sets A and B. They're overlap, so right here you have a common part, and then like 4 and 12 are only in A, and 9 and 18 are only in B. So what we need to do is try to write the elements of each of the sets indicated here. So what are the elements of A? The elements of A are going to be all the elements that are within this circle, which is going to be 1, 2, 3, 4, 6, and 12. It doesn't matter if it's just here or here as well, because this is set A, this entire circle. So whatever's in that circle is going to be an element of set B. So same, I'm sorry, set A. Set B is the same thing. So whatever's inside of that circle is going to be 1, 2, 3, 6, 9, 18. What is the union? The union is going to be all these numbers here. So just write them all. 1, 2, 3, 4, 6, 9, 1, 2, 3, 4, 6, 9, 12, and 18. What is the intersection? The intersection is what they have in common, which is this part. So that's just going to be 1, 2, 3, and 6. Correct? There's one more operation that I want to show you, which is sometimes textbooks make an emphasis of that, sometimes they don't, but there is a subtraction, and so A minus B. And A minus B is the set that's going to contain elements in A that are not in B. Just like with regular subtraction, the order does make a difference, and you will actually see it. So when you do want to do A minus B, A has 1, 2, 3, 4. B also has 2 and 4. So elements of A that are not in B, 1, 2, 3, 4, we have to take out 2 and 4. So that means we're going to be left with 1 and 3 only. Here's the thing, if you want to do B minus A, B minus A. Now you have to take elements of B that are not in A. So they do have the same two elements in common, 2 and 4. So B minus A will be all the the elements of B that are not in A, so there will be 6 and 8. Let's try to do B minus C. So B minus C, all the elements of B that are not in C, there is only one number like that, that is 2. And C minus B, well, C minus B, I'm going to give you a few seconds to think about this, but we want to list elements of C that are not in B. But here's the thing, every single element of C is in B. The answer here is an empty set. Alright, this is how it works, and I hope this helps. See you next time.